Earth a fragile world spinning through the vastness of space. To the untrained eye, it seems unprotected, a lone blue marble, vulnerable to cosmic forces beyond imagination. But that's not entirely true. Unseen, high above our heads, an invisible fortress hums with energy. A structure not made of steel or stone, but of charged particles trapped in magnetic fields. This is the Van Allen radiation belts, Earth's dynamic, shifting shield. A force field sculpted by our planet's magnetic field, constantly battling the solar wind and cosmic radiation. Without it, life as we know it might never have emerged, and our journey into space would be far more dangerous. What are these belts? Where did they come from? And what would happen if they vanished? Let's step beyond the atmosphere, into the electromagnetic fortress that surrounds us. From space, Earth looks serene, but just beyond the pale blue atmosphere lies a chaotic realm, a turbulent ocean of high-energy particles, moving at near light speed. These particles originate from the solar wind, a constant stream of charged particles from the sun and from cosmic rays born in ancient supernovae. To protect itself, Earth has a secret weapon, its magnetic field. Generated by the motion of molten iron deep within the planet's outer core, this magnetic field extends far into space, forming a giant protective bubble known as the magnetosphere. The Van Allen belts are part of that structure. They are donut-shaped zones of radiation wrapped around the planet, where charged particles are trapped and held by the magnetic field, spiraling along invisible lines of force, bouncing back and forth between the poles. To step into the Van Allen belts is to enter a world where physics dominates, a space sculpted by magnetism, energy, and motion. It wasn't until the dawn of the space age that we even knew the belts existed. In 1958, during the early days of the Cold War, the United States launched Explorer 1, its first successful satellite. On board was a Geiger counter designed by physicist Dr. James Van Allen. As the spacecraft circled the Earth, it detected something unexpected: intense levels of radiation high above the atmosphere. Not just a brief spike, but zones of consistent, concentrated radiation. A discovery that revealed Earth's magnetic field was far more dynamic and protective than anyone had imagined. And so, the belts were named after the man who helped find them, the Van Allen radiation belts. A quiet but vital part of Earth's defense system, discovered not by accident, but by looking upward with curiosity. So what exactly are they? There are two main belts, though sometimes a third transient belt appears during periods of intense solar activity. The inner belt, located about 1,000 to 12,000 kilometers above Earth, contains mostly protons, high-energy particles that can damage satellites and astronauts alike. The outer belt, stretching from about 13,000 to 60,000 kilometers above Earth, is dominated by electrons, lighter, faster, but equally dangerous. Together, these belts form dynamic, toroidal regions, like nested rings, shifting and changing with the solar wind. But they're not static, not fixed. They pulsate, expand, contract, and sometimes even merge, reacting to storms on the sun and geomagnetic activity on Earth. They are in constant motion, reshaped by space weather in real time. To study them is to watch a living system, electromagnetic lungs that breathe with the rhythm of the cosmos. The Van Allen belts are both guardian and threat. Without them, Earth's atmosphere would be under constant assault. High-energy particles could strip away the ozone layer, making the surface uninhabitable for life as we know it. But inside the belts, the environment is harsh. Satellites that orbit through them must be shielded. Astronauts passing through on missions like Apollo, had to move quickly to minimize radiation exposure. Too long inside, and the consequences can be severe: radiation sickness, damage to electronics, and disruption of communication systems. In this way, the belts are like Earth's moat, both a barrier and a challenge. They protect us, yes, but they also remind us space is not safe. It is powerful, and we must respect it. The belts don't act alone. They're part of a much larger system, influenced by the Sun, which undergoes an 11-year cycle of magnetic activity. When solar flares or coronal mass ejections erupt from the Sun, they send shockwaves of plasma and magnetic fields into space. When these solar storms strike Earth's magnetosphere, they can inject enormous energy into the Van Allen belts, causing them to swell, shift, or intensify. Sometimes, this leads to beautiful auroras, the northern and southern lights dancing in the polar skies. Other times, it leads to chaos. Satellites lose contact. Power grids are disrupted. GPS and radio signals falter. The belts surge with radiation. This is space weather, invisible but powerful, and growing more important as we send more technology and more people into space. As humanity pushes further into space, building stations, launching telescopes, dreaming of Mars, the Van Allen belts become more than science. They become strategy. Understanding them is key to designing safer spacecraft, protecting astronauts, choosing launch windows, predicting solar events. NASA's Van Allen probes, launched in 2012, spent years inside the belts, measuring particles, tracking changes, unraveling mysteries. What they found reshaped our understanding. They discovered transient belts, gaps in radiation, and particle acceleration processes more complex than anyone expected. We are still learning, still exploring, still being surprised by the force fields that surround our world. What if, one day, the belts were gone? A weakened or vanished magnetic field, caused by a planetary core cooling or a magnetic reversal gone wrong, could collapse the belts. In that future, radiation from the Sun would bombard the upper atmosphere. Ozone could be depleted. Surface life would face higher cancer risks, mutations, or extinction. Satellites would fail faster. Navigation systems would degrade. Earth would be exposed, naked in a hostile galaxy. Thankfully, our magnetic field is stable. It flips every few 100,000 years, but the belts return each time, reshaped, but still protective, still guarding life below. You've never seen the Van Allen belts. You've never felt their pressure, heard their pulses, or watched their storms unfold. But they are there, above you, right now. Invisible arcs of energy curving around the planet, breathing, moving, watching. They were born in the fire of Earth's core, shaped by its magnetic field, fueled by the Sun, and they have protected this planet for billions of years. They are not just science, they are our shield. So the next time you look up at the night sky, remember, beyond the stars, beyond the silence, a radiation belt sings with energy. And because of it, we are still here.